Welcome to the video presentation on formation of p-n junction. The rectangle represents the pure semiconductor bar. When one side of this pure semiconductor bar is doped by an acceptor trivalent impurity like boron, it creates large number of positively charged holes in this region. As it is a positive charged holes having more in number, the region is called as a p-type of semiconductor. When the other side of this semiconductor bar is doped by a pentavalent donor impurity like arsenic, it creates large number of free electrons which are negatively charged, and this region is named as the n-type of semiconductor. Addition to these majority charge carriers in each type of semiconductors, there will be a few minority charge carriers in both p-type and n-type of semiconductors. The terminal which is extended out from this p semiconductor region is called as the anode, the positive terminal represented by A. The terminal which is taken out from the n-type of semiconductor region is called as the cathode C. The area in between the p semiconductor and the n semiconductor region is called as the p-n junction. This p-n junction is technically named as diode, as it is having two electrodes for its external connection. And the symbolic representation of this diode is as shown in the figure below. Now, when this diode is created, the p-n junction, when it is created, the free electrons which are present just by the side of the junction in this n region, they will be attracted more towards the free holes existing on the p region of the semiconductor just by the side of this junction. As the attraction force is more in these holes, these free electrons which are quite free to move, they will be drifting across this p-n junction and occupy the free site of electron in this p region. Now, previously all these atoms were electrically neutral. With the accommodation of additional electron into these holes, those atoms will become dominant with one electron and they form negatively charged ions on this p side. Similarly, here on the n side near the junction, previously the atoms were electrically neutral. Now, losing one electron from each of these atoms, they become shortage of one electron and one minus charge shortage is created here, and one dominant positive charge on each atom makes these atoms as positive ions. This region where the ions are converted now, previously there were free electrons and holes which are the charge carriers, are now converted into the negative and positive ions here. As there are no free charge carriers available in this region is known as the depletion region. Now, further crossing of the remaining electrons, free electrons from this N region through this junction and occupy the free site of electron in this p region is opposed by the strong negative electric charge on this p region, and the further crossing of any free electrons from this n region into this p region is barred from this potential, and that is why this area is even called as the barrier region. In this depletion region or in this barrier region, voltage, due to the presence of these positive and negative ions on either side of the junction, a voltage gradient is created from this negative charge potential through this positive charge potential, and this would be of the order of typically zero point 0.5 volts. This voltage which is available at this PN junction or the diode junction is called as the barrier potential or the junction potential. This is how in a PN junction barrier potential or the junction potential is generated at the depletion region. And this is the same answer that you need to answer if you are asked to describe how the depletion region is created in PN junction. In the next video, we will see the functioning of this PN junction when it is connected with external voltage source.